Welcome back to another series on Rust programming language, and our goal is still one, okay, to be able to come to the point where we can understand the fundamental of Rust and use it to build blockchain technologies, right? And build amazing projects with blockchain. Okay, that's our focus, and we are journeying towards that. And so today we'll be talking about referencing, and referencing is actually another very important feature in Rust programming language that can also be likened to ownership, right? And so that's what we want to talk about in this video and how it applies to solve some of the crucial errors that other system programming language face. Okay, and so we look into that extensively in this video tutorial. And also in the previous video we talked about ownership and how what ownership is and the rules of ownership and what it does and how it plays a role in double freeing and helps us to avoid those issues. And we talked about function in ownership and return values in ownership. So if you know what that actually tutorial, please do well to go and pay a visit on it. Actually, it's very, very important you do that. Okay, very, very crucial you do that. And so having said that, so this is my file folder. So this is simply what is a normal file folder that you can create and name it anything and name it referencing, given the fact that that's what we're going to be talking about. And we've mentioned these things over time in our previous videos, so I don't really actually pay attention to doing it again. So I mean, it's very simple actually. Let me try and see if I can increase this. I hope you can see it much more clearer here now. And so as today's video we go, I will try and mix it up with both slide, and if there's any place I can do reference, I can do some illustration with my drawing. Okay, my animation actually it's not a bad drawing, it's just that I'm animating. Animating looks somehow like say it's bad, but it's not bad. This is my structure. So here we'll be doing some drawing, okay, while here, if there is any need for me to show us what it is, talking much of talking without even showing us picture, I don't know, it's visualizing something actually plays a role actually. And so please, I want to indulge you that you should pay close attention to this tutorial, this actual lesson, and know that if you didn't get it the first time, if you didn't get value from my videos or have not gotten value, just that you're not putting effort to try to understand what is being said, because I try as much as possible to break each and every section down for us to understand it precisely what it is. And so try as much as possible to actually give your best to understand it. You can actually, if you want to, you can understand it actually. It's not difficult. It doesn't matter whether Rust is your first language or it's not your first language. You can understand it if you want to. If you're giving your effort, you can actually. Okay, so let's dive into the video. And on my left hand side here is a slide, and on my right hand side there is a drawing. And so you want to start first of all by defining what referencing is, what it is, and what is not. So what is referencing? Okay, referencing is like a pointer to a value. Okay, there is a typo here. I was the one that constructed this myself. Apology for the typo. Referencing is like a pointer to a value, and it lets you actually access data without owning it. Okay, now when I talk about pointers, something should come to your mind based on the previous video. And if not, watch, try and go and watch the previous video. The previous video we talked about that values data that are stored in the heap are returns pointers. The allocator returns a pointer which is the address of where the data is being stored. And so referencing is also a pointer. Is it not a bit confusing? Actually, it can be, but there is a very, very vital way to differentiate between referencing and pointers, right? Pay close attention. So unlike pointers, okay, in heap, references points to an actual value, a valid actual value of a particular data type, okay, throughout the life of the reference. Now, this is what I mean. Let me just show us a very vivid example. Now, unlike like data that are stored in heap can actually point to an empty data. Like, right? Let me give this illustration. Let's age equal to string dot semicolon new. So this here on its own this variable here is pointing to an empty string in the heap. Okay, but what we see happen is that when this starts running and comes to this point, it will just know that we need to find a memory space for this variable, this man called age here, and the allocator will find a space for you and return the variable, the pointer, right? But in references must have a valid pointer. There should be a value that is pointing to, right? There should be a value that is pointing to. And now this helps us tackle what we call dangling references errors, right? That other languages like C++ and C actually face. Reference naturally, it helps us tackle that issue very, very, very well, right? And we still talk about it extensively in this session. Okay, so let's actually write some code to um, explain what this references is and how it works. So let's say s1 equal string from hello, and now this is a string that is being stored in the heap, right? Based on what we talked previously. I want you to pay close attention. Based on what we talked previously, and we want to create a logic, a function that once or that we calculate the length of something, or that can calculate the length of something. Let's say spelling spelling is hard. Calculate, don't mind me. Calculate length, right? And this we have a parameter, and the parameter will be a string type, right? This parameter will be a string type, and it will return a string and also a usize, right? And so and so excuse me. So what we want to do here is to just write a logic that will calculate the length of something. So you just do s dot or excuse me, s dot length. Okay, and pay close attention what is happening here, guys. Please, I want you to pay very close attention. Now you now do s this s and length. So what is happening here right now? What is happening here right now? Remember, okay, so let's length equals s dot this, and this will just put it in a curly bracket. Um, just do s2 and length, and just do equal calculate this thing and s1, right? And so we do print ln the length of Hmm, this S2 then. Now, pay close attention, guys. Pay close attention. Now, this is what is happening here. Calculate length doesn't really want to create its own value and maybe store its own argument here. Maybe write maybe hello world or something. But you just want to calculate the value of this man here. You know what Ross will do is to move the ownership of this person from this S1 here to this calculate value, calculate length here. And so S1 is no longer existing in this scope. In this men, S1 is no longer existing. There is nothing like S1 here, right? S1 is not existing at all. Pay close attention. Pay close attention. S1 is no longer existing here. And what is happening is that the ownership have been taken from this S1 to this man here. And so the S2, now this calculate length is stored inside this S2, right? And so because it's stored inside this S2, the S2 is now the rightful owner of this hello world. And so what is happening is that the calculate it's just like this value was moved from this point to this point. It just looks as if that's what happened, right? It just looks as if this is what happened. This value was moved from this point to this point because the value have moved already. Okay, pay close attention, guys. And so doing this thing this way, doing this way, we actually is not a better way, right? Because what if I don't want to own this value? I really don't want to own this value. I want to just access it and do whatever I want to do with it, right? I just want to access this thing and do the calculation without really owning this value. How will I go about it? What is the best approach for it? And now this is where referencing comes into play. But what this thing helps us to avoid, right? Now pay close attention. What this move, as I said in my previous video, helps us to avoid is to help us to avoid double freeing. And let's go to our slide and talk about what double freeing is. I call it data freeing here, but it's called double freeing, okay? And it occurs when you're trying to free the same piece of memory from the heap more than once. And so because now this hello, this S1 and this calculate length will be pointing to the same data in the heap. I talked about it previously in my previous video. And now if they have been used here, once they have been used here, the Ross will call the function drop to drop the memory. And so if it's trying to drop the memory, these two data variable that is pointing to one data will want to be dropped. And if Ross drops this memory for this, it will still want to drop this memory for this, and not knowing that these two are pointing to the same data value, and it causes a very big error, Ross language. And that's what is called double freeing. You're trying to free data, two variable that is pointing to the same data in the heap. That's basically what is happening, right? This is just what is happening, and that's why Ross automatically calls the move function. And so moving back to what we're talking about now, what is the best approach for this? Since I really don't want to own this, I just want to be able to just use this and be fine. I don't want to own it. So what is the best approach? Excuse me. What is the best approach to this problem? Now, this is the best approach is to call the referencing method. Referencing is that you're trying to have access to a data without really owning the value. Okay, you're not owning this value, you're just trying to borrow it. Okay, and know that the process of referencing to a data is called borrowing, right? The process is called borrowing. And so this is the best approach for this, is to call this method string Oops. Okay, so if you call this method, just change this referencing, and now this is not returning any string because it doesn't own it, right? It's just referencing to a string, so that's why we are wiping this. It's not really owning this string. What is just happening here is that this is referencing to a string in our data. That's simply what is happening here. I'm not owning this string and I'm just giving a reference to this string. So this is what is happening in our in our code here. So I'm trying to just clean this up a little bit. Okay. And we are removing this bracket because it's returning only one value, one type of value here. So what you just do is just put this ampersand. Okay, this is called ampersand. Is used for referencing in ROS actually. And so now this is what is happening here. Guys, pay close attention. Now this is now this value is still being owned by this. It's still being owned by this S1. And what is now happening here is that this man here, this calculate value, this function is trying to just borrow this for a while. Trying to borrow this function for a while and do the calculating and still return back the value to the rightful owner. And Ross is fine by this. And why this is throwing this error is because it's no longer available. So if you still call this F1, this F1 is still valid. Now what happened here is after we've used this if we've used this borrowed variable, right? We've used it here. Okay, Rust will try to drop the memory, but when dropping the memory, this is still available, right? And remember our definition. I remember what we said, that referencing points to an actual existing value. We still talk about it while we go down. Now this is what referencing looks like. I'm trying to assess the value of this data without taking an ownership of it. I don't really want to own this data. I just want to do is just to borrow it. It's like when you maybe you have a neighbor or a friend that you maybe because of some reasons your gas finished, you just went to borrow gas from the person, or lighter, or just anything, right? You're not, maybe because that day you don't want to go outside to buy something, buy that, you just want to borrow and return back. You're not claiming an ownership of that, and that's really how Ross works here. That's how referencing works. I'm trying to access this data in the heap here. Okay, I'm trying to access this data in the heap here, and I don't want to own it. I just want to use it and do whatever I want to use it and do, which I've used here. And after using it, I'll drop it back. So what we want to do is just to call a function, and let me just clean this up a little bit. Okay, yes, and clean this up a little bit. Okay, so let me just call cargo run, and see that this thing will still work perfectly fine. At the compile time, there was no error actually. You see here, there was no error at the compile time. So it's saying that the length of our hello is 5, right? But in our previous example where we use the move will still run perfectly fine, but that's not really what you want. You don't want to really be moving your value around from one point to another. We want to be able to borrow this in and do whatever you want to do and return it. And it helps also in the efficiency of our memory and our runtime actually. Without I'm not owning this, I'm just trying to access it, and it works perfectly fine. And so what really changed in our value from our previous one is that we are now actually borrowing this value. Now This is where we wrote our previous logic, okay, and we are trying to call this logic here, okay. Previously what we will do is to add a value in our argument, right, which is here. Just add a value in argument when we talk about functions, right? But now we really don't want to stress ourselves in having our own value, but there's already an existing value in our scope. We want to just access it and borrow it. So instead of us to just call this s like this, right? If I'm calling this s like this, now what I'm trying to do is to just have own this value totally, and owning this value is not really what I want to do. I just want to have access to this and do what I want to do and actually go my way. And this ampersand is a very vital operator in Rust. Okay, if you add this ampersand, that means that you are trying to reference to a value. And remember our definition of referencing. We said that referencing actually helps us to, it points us to a value. It points us to a valid data. Now this is a pointer, this reference here is a pointer to an actual existing data, right? This is a pointer to an actual existing data. And note that this as long as it exists, Ross must make sure that this function, this s1 here, this data here is really valid until this calculate length is being dropped, right? Ross make sure that this thing is being valid till this is dropped, right? This can drop first before this. So that's how strict Ross is, okay. And so let's assume that we really want to modify this referencing. If reference to a value and we really want to modify something in this value, we don't want to take an ownership of it, which we've talked about, and we now want to modify the content, okay. We want to modify the data in this value. What will we do? Okay, what will happen? How can we do that? Okay, so let's write some code. I'll just clean up this. Okay, I'll just wipe up this and just do the same fn and just save this. So what you want to do is just to know if you can modify a string or a data or a value, actually how you can be able to modify a value. Okay, so let's write some code and to understand this very well. Let's say let s equal string from hello. So we've created a value here. Let's create another function, change. So just write the parameter, pass a parameter here, some string, and this we don't, now you want to reference to this value here, you don't want to own it. So what you do is just to pass this ampersand and just call this string here, this string function, and we are good to go. So what is happening here is that you really want to, we are referencing, you are pointing back to a data. Like this is pointing, this ampersand helping to point back to an existing data, right? That's simply what it does. And so what I want to do is to just pass this parameter here, something dot push underscore old. Okay, so what will happen is that I'll just call this up here so that everyone will be fine, right? Change ampersand s. So this, if this works, is actually the same way our previous code worked, right? This is just the same thing that our previous code was doing. So we are not trying to have ownership of only this is that we remove this ampersand like this, and this value s have, the value of this s have already been moved from s to this, and s is no longer valid, right? And that's not what you want to do. And now looking at this, what is really wrong about this code? Remember, what we are trying to do is to modify the existing code, right? We want to modify, be able to modify this variable here. We've had access to this variable, right? We've had access to this variable using referencing. We have borrowed it. We are not owning it, we are borrowed, but we want to be able to modify this variable. What is the missing link? Remember when we talked about variable, that the rule of variable is that variable by default is immutable. You cannot change the value of a variable. The same way referencing by default is immutable. You cannot change the value of a reference at by default. Sorry, by default you cannot change the value of a reference, right? And so what is the best way to go about it is to add that mutability there, right? For you to be able to access it, just add that mutability here, and we have to start with this our variable here and add mutability, and in our string here, in our reference here, actually we need to tell the reference that okay, we want to really access this value without taking an ownership of it. I want to modify this value. Actually, that's what you want to tell this man here. That's what you want to do, is just to modify this value, and we are not actually here to cause trouble, right? And here too, you just have to put the mute here, and everybody is fine. And now this is how we can modify in Rust programming, and we can modify referencing. Okay, remember, take note that referencing as variables are immutable by default. You cannot really change their values, right? You cannot change their values, but there is now a catcher here. Okay, there is something you have to now pay attention to, which is where this our slide comes into play. Okay, he said that if you have a mutable reference, okay, to a value, you can have no other reference to that value until it is being used or dropped. Okay, and so adding mutable references like this, okay, is saying that whenever you're using these mutable references, that means that you cannot really have or you're restricted to having any other mutable reference or any other reference at all until this mutable reference has been used and dropped. Hope it makes sense. So that means that provided you've introduced a mutable reference to your code, okay, provided that mutable reference have not been used, provided the mutable reference have not been used, right, it is still valid. And if you're trying to introduce a maybe immutable reference to that mutable reference, or trying to introduce another mutable reference, Rust will really kick against it. Rust will throw an error. Why Rust will throw an error is because of what we call data racing, right? And we talk about it. And so now you're trying to introduce two variables that are actually trying to modify a data, or one of them is trying to modify a data, or another one is using a data. Rust we actually at compile time, actually there will be an error. And so let's actually write a code that actually violates this rule and see what will happen. Okay, let's still keep our hello world. Let me just comment out this. Let's still keep our hello world. This is no longer existing. I'll just comment this out. Okay, so this is our hello world, and so let's actually write a variable that violate this rule of referencing rules of mutability. Okay, so let's say and percent mute s, right? Let's r2 equals and percent mute s. So print ln r1 r2. So this is what we're talking about, that there cannot be two mutable references pointing to the same variable, or a mutable and immutable reference pointing to the same value until it is being used. That reference that is pointing to the data is being used. And now this is what is happening, that this variable s2 and this variable r1 and r2 is trying to modify the same data. Now let me help you to picture what is happening here. Okay, but first, now this is called data racing in Rust language. This is called data racing, and let me just try to explain what data racing is. Now, data racing is when multiple people or variable are trying to modify or access the same data, right? And this is what is happening here. This variable and this variable are trying to modify and access the same data. This is what is happening here, and this is what we call data racing. Okay, and ownership, borrowing, and lifetime actually helps us to manage this data racing. And lifetime, we talk it in the coming sections series actually, but now this is how own referencing actually helps us to manage this data racing. This have already called an error at compile time, that no, something is being wrong here, that I really don't understand. You're trying to modify two variable at the same time. And now this let me just explain this in a way that we will really understand it. Let me use my drawing board. So let's say that this is Mr. A. Okay, Mr. A here, and this is Mr. B. I'm trying to explain what data racing is and what is happening here, right? So this is Mr. A, this is Mr. B. And so imagine that this man, that you built a hotel. Okay, imagine that you built a hotel, and you actually furnished the hotel, and the hotel is hello, right? Just imagine with me that the hotel is hello, right? And for some reason your receptionist now try to give s1 r1 a master key to a room, okay, to actually modify it or to change it or just do some designing on it, right? And at the same time, the receptionist also gave r2, right? Gave r2 the same another master key to the same room at the same time, to modify the same room at the same time. So now r1 and r2 is trying to make a change in a particular room at the same time. And so now what happens is that r1, which is Mr. A, and r2, which is Mr. B. Let me just write r1 here. r1 is Mr. A, r2 is Mr. B. So these two candidates now, let's say that this r1 is trying to do painting, right? It's trying to paint something. It's trying to paint something. Okay, paint the wall of the room, and r2 is trying to just maybe bring down the walls or just scrape out the walls of the room. Okay, this arrow one is doing painting, arrow two is actually pulling down the wall because of maybe you have seen that the kind of way that he wants to the painting to be. Like now, this will cause a very big chaos, which is called data racing. You know, two variables, Mr. Arrow one and Mr. Arrow two, are trying to bring change at the same time to the same room, to the same variable, to the same data. It is a very big error. And now if you can imagine it in a room where two people are trying to make changes at the same time, this one is doing this one is doing this, is doing that, it will be a chaotic moment. I mean, they will end up fighting, and it's not visible in our day-to-day life, right? Right, it's not visible. And now what happens in our code is that now Ross comes in as a very strict hotel manager and says no, no, this can't work, I don't like this. Okay, is if you can give one person the master key at a time, and if you want to give, if you want to give Arutu access to modify the same room, you must make sure that Arrow one have already returned the key to that room. And so since Arrow1 wants to do painting and Arutu wants to do the same painting, but he wants to start scraping down something, or they just want to do anything at all. So Ross, which is a strict hotel manager, we say, okay, now Arrow1, you go first and do whatever you want to do and return back the master key. Then Arutu will now be given the master key to now do modification of whatever he wants to do. And so that's how Rust uses referencing to manage how data racings happen. And so you must notice that now this is an error here. This is an error here. Okay, this is an error. Ross, as a hotel man, is saying no, that this must be used, arrow 1 must be used first and dropped before arrow 2 can come to existence. Now, this is what we are talking about. So let's try to use arrow 1 first, and you find out that this error will just vanish like smoke. Okay, so we just do this and just call arrow 1. Okay, and we will just clean up this arrow 1 here and clean up this code. Just clean up this code, right? And see what happened. Boom. Now they are all fine, because what is happening? Remember, this is what is happening now, that S1, this R1 have been used here and dropped. So this is the scope of this S1. Immediately S1, this R1, sorry, not S1. Immediately this R1 passes this line, the Ross will automatically drop it and now go over to this person. Now Ross knows that, okay, that these two variables are not trying to modify the same data at the same time. These have been used here, okay, and we are now calling the second variable, and it is now being used here, right? And another thing to also note about this is how Ross handles data racing. And now there is no two variables that is trying to modify a data at the same time. And an important truth to know about data racing is that, you know, two or more references exist to the same data. Okay, that's when data racing happens. When two or more references exist at the same data, they are pointing at the same data. This is what we are talking about here. Okay, they are trying to modify the same data, right? And the second one says that when at least one of them is writing. So writing is meaning when one of them is trying to modify a code. And so now you might have an immutable reference here and a mutable reference, and Ross is not happy about it. Let's write some code to explain it. Actually, let's just see it in work here. So x, let me just say that this is referencing, right? This is just referencing. It's trying to read the data. It's not trying to access anything. Okay, you just do this and do arrow 1. Now, this is what is happening here. The compiler have already thrown an error, right? And this is how ROS manage data racing. And we say that data racing happens when at least one of them is trying to modify something. And so between these two now, this is trying to modify something, right? This arrow2 is trying to modify something in our code. And so think about it as when two people, one is trying to view how beautiful, see the beauty about a particular room. Another person is trying to do the same painting and do the same renovation at the same time. It doesn't make sense. I'm trying to picture how beautiful or trying to read how the room is, how good the room is, but the other person is trying to repaint. It's crazy, actually. It's chaotic. And so this is what happens in other languages, other system languages that that ROS actually handles, okay, using referencing. So this is called data racing. And so the old one, okay, what makes data racing is that means that there is no control over time synchronization, right? There's no control over time. Now, how can you say that Mr. A and Mr. B, you don't know when one is doing one and when the another is doing another? So it's just a chaotic place to be. It's not a place anybody wants to be in real life, right? You can imagine it where maybe your let's say you're trying to wash the toilet and your brother is still pooping at the same time. It doesn't make sense. And it's crazy. It's crazy. Or you're trying to do something, another person is doing an opposite of that thing. Like, it's really crazy, right? And so this is what is called data racing. They are racing to just bring about modification on a particular data, and Ross tries as much as possible to control it here, right? And now remember that if we try to use this, let's use this here, print ln this, and just call arrow1, and you just call arrow1, and you just clean up these guys here. Our compiler will be really fine. Okay, everybody will be fine, and if you compile this, it will work. So at compile time, everybody is fine because this have been used here. Okay, it have been used and be returned. So this referencing have been used, and provided it have passed this scope, the referencing have been returned. Now this arrow and borrow this to just modify it, and immediately it crosses this print ln here. Okay, the borrow, you have this arrow and have already returned back what it borrowed. So this arrow2 can now have access to the same value, right? Arrow1, this a have already returned the key at print. Have already used and do whatever you want to do and return the key. Now arrow2 can now have access to the same data. This is just what is happening here. This is just what is happening here. So let's return to our code here. So now this is what data racing is, and this is how ROS handles data racing using referencing. Okay, I hope it really makes sense. I hope it really makes sense. And now come to think about it, let's also talk about one crucial important and by the way, if you run this cargo run, you should print, like, actually you should print hello. You should print hello. So both of them are printing hello. These have been used already and dropped, then this is now used, right? This is just what this is saying. Okay, there is no other. It's just a simple, very simple logic. Okay, and now let's talk about another crucial important detail in a ROS language called dangling referencing errors. And so remember our definition of referencing. Okay, that referencing points to a value. Okay, is a pointer to a value, and all that we've been doing here have been pointing to an actual value. So this is pointing to a value, and so we say that referencing, the difference between referencing and the ownership pointer that you talked about is that referencing points to an actual existing data. Okay, and I said in the beginning of this video that it tackles what we call dangling errors. Okay, dangling referencing errors and Rust actually handles it, while in other languages is actually a very big and a very critical issue. Okay, and so we've talked about double freeing, we talked about data racing, and we want to talk about um, dangling errors now. So what we have to do is just to do a simple, let me close this. Let me close this. Okay, so you just comment this out. Let's comment this out. I'll just start from here. So you just want to write a simple code, and we still use our hotel illustration to understand what this is. So let's write a function. Let's write a simple function here. Say fn just dangle. Just call this function dangle, and this function we have to return a reference to a string, right? And we say let s equals string from, let's say room 205. We say hello. Okay, just saying that this return from room 205. Just say hello. Oops, hello. Okay, and mm, and this will return our s, right, our string. And so what we want to do here now is very simple. You just call this let room. Now I will explain what is happening here. Let room print n. Okay, so there's an error here, and this error message is happening at compile time, and this is what dangling referencing means. So let me go back to our slides. Okay, so dangling referencing is a pointer, okay, to a memory that is no longer valid, right? So provided that this memory, the memory you're pointing back to a memory that is no longer valid. So let's say that you actually had, let me go back here. So you entered a hotel room, right? So let's imagine that this is the hotel, and you requested for a room, and this room you stay for it just for a night, right? And you are given a key card to that room, right? And so it is actually expected of you that at the end of that night, in the morning when you're checking out, you should actually maybe you should actually return the key card, right? But for some reasons, you checked out and you went with the key card with the intention that you come back maybe tomorrow or in 2 days time, and because you love the room very well, maybe in 2 days time you still come and maybe have access to the same room again, right? And this is exactly what is happening here. And not knowing that immediately you checked out of that room, you're no longer immediately you checked out of the hotel, you're no longer an owner of that room. And so for some reasons, after you checked out, the receptionist will maybe assign some cleaners to come and clean the room and do some cleaning on it, and maybe give it out to someone else, right, that's looking for room. Or maybe for some reasons they change the key lock, or they notice that okay, that for some reason they just change the key lock, right, and there is not a new key to it, or um just something, right. So the idea is that this room that you are assigned to, when you check out, right, you're no longer the actual owner. Like you're not really an occupant of that room again. And so think about it like this, that this is the hotel you just entered, and this is the room you are assigned to, and this is the key card, a reference to the room, right. Like it's telling you that this is the room, that if you fill the card, you just have access to the room, right. Okay, just a reference to the room. And when you check out, which is outside here, when you check out outside here, you have no access to that room again. And so when you come back the next day saying that, oh, this is the card, I want to have access to that room, you have a key card that is pointing to no room at all that is your own, right. And so because this room you're pointing to now, somebody else is occupying it, right. And this is how Ross really handles dangling referencing errors, right? Remember what we talked about scope, that scope is a range within a program of which an item is still valid, right? And so now this is valid, this reference is valid provided it's still in the same scope. And so going out of this scope, Ross will immediately drop this value, right? And that's just basically what is happening. Ross will drop this value. So if you run this now, I can't go run, it will actually throw an error. And so let's see what the error is saying. Okay, it's saying that returns a reference to a data owned by the current function. Okay, and cannot reference to local variable s, right, static. So it says that instead of you are likely to want to return an own value. So we still talk about this lifetime in the future. I know that lifetime was mentioned here. We still talk about it in the future, right? Saying that this function return type contains a borrowed value, but there is no value for it to be borrowed from. Does it make sense? So this function returns a borrowed value, but there is no actual value for it to be borrowed from. Why? Because the function that is trying to borrow it was declared here, right? It was declared inside the function itself. And so if you're trying to call this function here, this will be dropped automatically. This function will be dropped because it's out of the scope, right? And now there are two ways to go about what Ross is expecting for you to do is for you to own this data, right? Only is that the ownership is now moved from this to you're now the sole owner. It's like now when you now return to the hotel, right, you return to the hotel, right, with the card. What is expected of you is that before you take that card and go, just leave the card and have an ownership of the master key. So the hotel will now assign that this will be your permanent room forever, provided that you're still alive. This is your permanent room. Now the ownership has been moved from the hotel or the receptionist or to anybody to you in question, and so you're the rightful owner to this data, to this room. And so this is what is happening. This is what Ross is expecting that you should do. And so this is how Ross actually handles it. Okay, pay close attention. This is how Ross actually handles it. This dangling errors. So Ross is expecting that you take a full charge of your because this is referencing to something that is not existing, right? This string should return a reference to a data. Now I'm trying to make it so that we understand and be at the same page. This string is returning a reference to a data, right? And this is actually a function inside of this. This is a logic inside of this function, and so this is pointing to a string that is not existing, right? It's pointing to a string that is not existing because when this after this thing has been run, this is dropped. This s variable is being dropped because it cannot be valid outside of this scope, right? When we talked about scope, right? And this is what we can do, is to just take the full ownership of this variable and own it. And when we own this variable, Rust is really defined. There will not be any compiling error or such. So now the compiler is fine actually, right? It's fine. And this is how Rust handles dangling errors, pointing to an invalid data. Now this is now the rightful owner of this string. This is running a string, right? A string, and this is the string here. And so if you call this data, it will actually print without any error. You say room 205 hello, right? This returns with no error. And so there's still another way to do this thing. Okay, now this data is being actually called here, and this is why there is actually Rust is throwing an error, right? But assuming that we call that this hotel room, or this variable exists in our main, right? There won't be any error, because now this is referencing to a particular string, and there is actually a string that is being referenced to. Because now this, do you understand? I hope you understand, because now this ampersand is in this scope. So anything outside of this scope, this variable will be dropped and the memory will be clean. And so if you declare this thing here and call this dangling here, okay, there will not be any error of any such. And so this is how actually Rust handles dangling errors and in Rust language. Okay, I hope it really made a lot of sense for us. Okay, and the major thing I want you to take out of this is to pay close attention to the details of how, if I'm these videos, as I'm doing it, I'm still making references to what we talked about before. We talked about scope, we talked about variable before, and I mentioned variable here, and we talked about ownership rule, and I mentioned it here also, and function also, how function works, and I mentioned it here also. And I just want you to just see the relatability, how this links to each other, how we are building on top of each other, right? And so this is what referencing are. We've talked about what referencing are. We talked about how to modify referencing. We talked about data racing and how reference handles data racing. We now talked about dangling errors and how Rust handles dangling errors using referencing, right? And so try as much as possible to go through this video again and again and pay close attention, guys. It's really important. I guess I didn't use much of this my board today, but try as much as possible to subscribe and just share with friends. And actually, this is a message for you. Don't think that this is not for you. Whether you have passion for programming, right? You have passion to learn, you have passion to program. Learning can be vast, right? You have passion to be a programmer, and this is your passion, right? It's what you want to do. Don't say that this thing is too hard for you. Actually, it's not hard for you. It's just that you're not giving it your best, right? If you give it your best, if you give learning your best in what you want, you see the fruitfulness thereof, right? You see the fruitfulness thereof. And now try as much as possible. Try as much as possible. This is showing an error is because we are still referencing to something, right? We are still referencing to something that is no longer valid. And so try as much as possible to pay close attention to learning, right? Learn well. Pay close attention to learning well. Okay, is a very important discipline, that you stay on something and try to see what this thing is. Okay, believe me, I try as much as possible to break this thing down so that you'll be able to understand precisely what it is and what is not. And if I can teach you, you can really understand, right? Give it your time, give it your thought.